Hi guys, in this video we will see one common design or interview question. What is the open-close principle? So let's get started. The open-close principle says that our designs should be open for extension but closed for modification. So how do we think about that? Well, imagine a project saying to you, feel free to extend our classes with any new behavior you like. If your needs or requirements change, just go ahead and make your extensions. And imagine the same project saying to you, we spent a lot of time getting this code correct, so we can't let you alter the existing code. Well, that sounds a bit contradictory, doesn't it? So, how can we extend the behavior of a system without having to modify that system? As it turns out, there are some clever object-oriented techniques for allowing systems to be extended even if we can't change the underlying code. Let's focus here on understanding the general concept of the open-close principle, and let's do it by looking at a simple means of allowing extension through composition while at the same time protecting the existing code. Initially, our drive method just allows the car to drive in a normal car way by acceleration, clutch, brake, and gear shift. At some point, we want to make the behavior a little more elaborate, and we add an automatic method so that for automatic cars, it does not need manual gear shift and the clutch. Finally, in the application, using the car class, we need to support intelligent manual cars that don't have clutch but needs gear shift. Now did you notice that every time we added a new aspect of driving to the drive method, we have to open up the drive code and make addition. We are violating the open close principle. Well, what if we approach it a little differently then? Let's say we have a set of driving types, sort of a little family of classes that know all about how to drive in different ways. And why don't we define an interface or an abstract class to represent driving behavior? It will have just one method, drive. And then we'll implement that with our manual and automatic drive classes. Alright, how does this work with the cars now? How do we connect the two? Well, instead of inheriting drive behavior, let's have car composed with the drive behavior. In other words, a car has a drive behavior. Now when we instantiate a car, we are also going to instantiate a drive behavior. And then we will compose that with our car. Or if it is automatic type car, we can compose our car with automatic drive behavior instead. But we never added that behavior for the intelligent manual cars. I guess that means we are going to have to open our car class again and add the new behavior. Well, no, actually we don't have to. With this new design, we just need to implement our intelligent manual class and then we should feel free to use it with any car as we need to, even if the car was written before the intelligent manual class was implemented. So with a simple technique, we found that we can implement any number of drive behaviors and we can add them without altering the existing code. This is one of the many techniques for allowing a design to adhere to the open close principle. That's it for this video guys. If you liked the video, please like and subscribe.